Is it?
Yeah, now it's recording.
Okay,
You can
great.
see from the top left.
Oh, yes, thank you so much. I am recording. All right, so we're being recorded. And right after class, I am meeting with a technician guy, so we'll be uploading the videos to Virtual. I have slightly adjusted changed the slides a little tiny bit. I've added a couple of phonology things to Applied Linguistics 4. Okay, so it's kind of the content that I had uploaded. So if you want to re-download it, download it. And what am I doing? I am sharing my screen. Now this is a visual sort of graphic representation of this idea of what neural networks do. Okay, so it's meant to show like this concept of activation that's borrowed from what neurons do in our brains. So the nerve cells in our brains are they send electrochemical signals, and they are connected in networks to other neurons in these, and they can send an activating signal. So a neuron fires, sends that activation, and then has a resting state. And then it can fire again, and neurons can excite other neurons. So send, like say, cause another neuron to fire. Fire meaning this is an electrochemical signal. Obviously, this is just a simulation. These are actually mathematical formulae, right? So here I'm just showing you like what it would mean to build a neural network, which is the one that Gary Dell proposed to account for language production. Okay, so think of this as energy. It's sort of things can have, it has a sort of the activation function is such that when it reaches a threshold, so a certain value, then it fires. Okay, if it doesn't reach that threshold, it doesn't fire. And the idea here is that this model accounts for how we produce language under normal circumstances. It accounts for errors that humans normally make under normal circumstances, but it has also been used to account for those kinds of errors that happen after a stroke, when you actually have real deficits in naming, like so it's actually a really interesting application of this model to account for normal production and impaired production. So the idea is that you activate semantic features, picture of a cat, and these are lemmas, the one where the sort of the nodes corresponding to cat, rat, mat, dog, and fog. So cat is the target lemma. Normally you would say, well, that's a cat. But you may, in fact, end up sometimes saying dog with a certain probability. You may be more likely to say something like rat, because here the idea is you have both semantic overlap, cats and rats, the semantic associates, but cat and rat also share more phonemes than cat and dog do. So the idea is that rat, other things being equal, is going to get activation both from the semantics and from the phonology. But each one of these representations will have some activation, including phonologically related words that are phonologically related to a semantic competitor. And then here we also have mat, which is also a semantic associate. Okay, so all of these will have some activation. Now, it may seem weird to you that you would say fog, right, when you want to say cat. However, in some naming deficits after a stroke, that is actually possible. And the reason is you've got your inhibitory links not working. Something in this process means that you're more likely to produce these, they're called paraphasias, right? So the dimensions that influence this kind of naming deficit are both semantics and phonology. And if the network is, let's call it the network, so under certain circumstances, these networks can account for the naming patterns in people after brain damage, which makes it kind of interesting, both sort of in terms of like basic science, but also these kinds of applications that have, in this case, would have clinical applications. All right, so here we have our concept: cat has whiskers, is a pet, has fur, has a tail, etc. They will also activate other concepts that have those characteristics. So for example, dog, but then dog and rat. Okay, so rats have whiskers. A rat isn't a pet. Okay, a dog is a purr. A dog is a pet. I said purr. Did you hear that? Why did I say purr? That's interesting. Did you hear me say purr? I did say purr. A dog is I said a dog is a purr, right?
Because you wanted to say pet.
Yes. And I also saw, and cats purr, but visually, I saw here, it says has fur, right? So see that? That's kind of, again, it accounts for how you can have multiple inputs that are, in this case, I had fur that came from both like the visual, but also cat's purr, and I was going to say pet, right? So that's an example of a mixed error. That just happened, okay? So these things happen, and here you've got dog, cat, rat, and fog. They'll all receive a little bit of activation. The fog picture didn't show up. The idea is that the r phoneme will get some activation. Here I'm using the intensity of the color to show what's more or less activated. So r, d, and k, if I produce, so this activation spreads through the network. This is before lemma selection, okay? So in this interactive, so activation here is both cascading, meaning you don't wait for the lemma to be selected for the whole network to actually receive some level of activation. And this is before lemma selection, okay? So here these lemmas are competing, cat and rat and dog. And then at some point, oh, there's fog, okay, and mat. So then let's say now we've selected the correct lemma. It has to then be phonologically encoded, okay? So it's then passed sort of down to the phonological encoding network. So the most active lemma is linked to its syntactic frame. Let's say there's a cat, you want to say the cat chased the rat, right? You have to assign it, you have to give it, put it in its correct frame if you're going to say a sentence that contains cat. And then that sends activation back to cat, okay? And then activation spreads through the network, and now we're doing lexeme activation, okay? So cat, the cat lemma doesn't have phonology. It's connected to its phonology, but it's not the same thing as its phonology. And then you do phonological encoding. In this case, you select k, a, and t, right? So what I demonstrated when I produced the error was this error that was a phonological error, but the source of that error was mixed, okay? So what looks like a phonological error could in fact be also influenced by the semantics in this kind of network. So the most activated phonemes are selected, but other phonemes are also active, okay? So this accounts like, okay, so this is like if I say, I want to say cat, I say, and I end up saying cat, and everything's okay. And that's what you end up saying. So crucially, the crucial features of this type of architecture is information flow, activation, spreads all the way to the phonology, and the phonology can feed back up, which is very different. So there's similarities in terms of thinking that there are different levels. You've got the lemma level, you've got the message level, the lemma level, and the phonology level. So the Bach and Levelt model has this kind of architecture, but the information flow or the direction in which you allow activation to flow is different. They only assume, that you complete lemma selection, then you do phonological encoding. You don't allow phonological encoding to influence lemma selection. So lower levels in the interactive activation model are allowed to feed back to higher levels and influence lemma selection. So that's why it's called interactive feedback. So this type of interactive activation model accounts for semantic errors. Okay, so these semantic errors happen because you activate conceptually related lemmas, and they can end in an error if I say dog and I meant to say cat. The reason is for some reason that dog received more activation. It was selected. Okay, so this accounts for those semantic substitution errors, like when we say dog instead of cat. So this is sort of the idea here is that you've got these sort of top-down semantic errors. In this case, the image just shows you this is an error. I wanted to say cat, I end up saying dog. Why? That lemma ended up receiving more activation and gets selected. Now this is an example of an error that's actually coming from feedback from the phonology. Okay, so both cat and mat are activated. So cat activates the phonological network, that here the a and the t, but for some reason, which could be exactly what I did earlier, like some reason, you also end up selecting something that is phonologically related. Okay, so it's selecting the wrong lemma because it's influenced by phonology. And this type of error is hard to explain if it's only one directional. So the Levelton-Bach type of model wouldn't account for this. You wouldn't allow phonology to influence lemma selection. And now this is an example of a mixed error. Okay, so mixed, we said, has both semantic and phonological. So for example, I want to say cat, but I end up saying rat. Why would I do that? Well, rat receives activation both from the semantics and from the phonology, because it overlaps in phonology, and in this case gets the explanation is that you have both this top-down and bottom-up activation. Okay, so those are just examples. So in some sense, errors are like, you can think of them as breakdowns, temporary breakdowns, normal breakdowns in lexical access, meaning selecting the wrong lemma, okay, which can happen both under normal circumstances in all speakers and a lot if you have an impairment. The idea here is that the same network can account for both, like what's normal in speakers and then what actually is pathological in terms of like how frequently it occurs. Okay, so you can have different breakdown points in the network. So the first one is from the semantics to the lexical network, and here you actually have mostly semantic errors. But you can also have a breakdown, meaning you have interactive activation coming from the phonology, and in this case errors are mostly phonological because of feedback from the phonological network. And interestingly, you can also have errors that look phonological, but in fact can only be explained because of interaction. Okay, so the example I gave you, the one I produced, saying per instead of pet. I actually said per instead of pet. Okay, so that was an example of something that looks phonological, but it actually was accounted for by both semantic and phonology. Okay, so when we produce the point here is that every time we select a word, this is a competitive process. We're actually doing this selection of a candidate among competitors, and these competitors are both semantic and phonological. Okay, anytime you produce any word in any language. And the next step is phonological encoding. So once I've selected a lemma, I have to phonologically encode it. So retrieve its lexeme, okay? And this can go wrong. So I wanted to say pet, the example I produced. I wanted to say pet. I said per, why? I'd selected the lemma and then I sort of did a phonological encoding. Something went wrong in phonological encoding. I noticed that pet and per both have, like, it's one syllable, they both start with p, right? So the p phoneme was active in my plan, and then it also received activation, in that case from the semantics, okay? So in this interactive activation type of network, there are two different sources of what look like phonological errors. One's purely phonological, and the other one is phonological plus semantic. And this is interesting, for our purposes to understand normal language production, but maybe we're less interested in understanding exactly why this happens. But it is very relevant to understand where somebody's naming deficit is if they happen to be aphasic, which is kind of interesting, right? To understand where is the breakdown in somebody's naming patterns, okay? So this is an example of a model that was developed to account for normal language production, then it manages to account for all kinds of circumstances, normal speech errors and errors made by people with brain damage. And again, the data from people, so the data from people with brain damage also help you understand how normal production works, because you can actually ask them to name and collect. So you give people pictures and you ask them to name these pictures and you look at the patterns of errors, right? So it kind of gives you an account of the whole range of human production in this when we do single word naming, okay? And the two factors that influence naming errors are phonology and semantics. So in Levelt's serial model, meaning stage serial model, we remember lexical access is staged and you wait for lemma selection and then you do phonological encoding. Okay, so syntactic processing precedes phonological processing. In Dell's interactive activation model, you have interaction between the lemma, and the phonological processing level. Okay, so this is like they share similarities in terms of architecture. Where they differ is in terms of information flow. And interaction makes errors more likely, right? It actually means that it is a more complex system if you also have interaction. Okay, so if our minds work interactively, it means we're more like, there are more sources of errors. So you can see that if it were just a stage model, you would have fewer sources of error. Okay, so an interactive model is more powerful, but it's noisier in a sense. There's more possibility that you will actually produce errors. So this is just a wrap up, right? The Bach and the Welt reading. Okay, so I'm just they summarize at the end of the chapter things that are important to remember about production. The fact that when we talk or when we produce language, this requires assembling linguistic units at different levels of representation, and we build linguistic structure accurately and fluently in real time. There are challenges to studying language production from a sort of linguistic point of view. So there's the issue of trying to control the message. So that's why we give people pictures or translation tasks where you know what the content is. And so that psycholinguists have developed many experimental methods. Okay, so there's still, the difficulty of studying production versus comprehension still remains. In comprehension, I can give you a passage to read and understand, or etc., and I can look at what happens. In production, you're trying to elicit production. Okay, so there are eye tracking technologies that you can use in production, so to trace the time course of language production. These are used also in interpreting studies. So interpreting studies look at what happens when interpreters understand and then produce a language in another language. So there's kind of a large field of sort of like the psycholinguistic studies in bilingual processing and interpreting. Okay, so some of them are experimental, some of them use technologies like eye tracking, and of course understanding what the brain is actually doing, right? So increasingly we can look at this. So understanding what our mind does, like the biological functions, the neurophysiological underpinnings of language production. So multiple methods, from all the way from observational to experimental. Okay, in the chapter, Bach and Nevelt use a simple sentence, an example of a sentence. This is the sentence they used. She was handing him some broccoli to show how the model of language production works. And this model is built to account for the production of single words to complex sentences to paragraphs to discourse, right? Clearly producing sentences is more complex than producing single words. And I said that in the exam, one question to check your understanding of the model is to illustrate how the model works, asking you to come up with a sentence given a verb. Okay, so that you should understand like what's the difference between types of verbs in English, okay, intransitive, transitive, ditransitive, and then you can choose what sentence you want to come up with and show, for example, where possible breakdowns. Okay, so just like she was handing him some broccoli, he was handing her some broccoli, but that's a function assignment error, right? Something like that. You're obviously free to choose what kinds of sentences you come up with. And remember, in English, for datives, for ditransitive verbs, you have the option of doing a prepositional dative or a double object. And then you've got actives and passives, right? But these are the sort of, this kind of exercise is useful to check that you understand how the model works. And the exam, you are allowed to look at your notes, okay? You're allowed to look at the book, you're allowed to look at the slides, etc. I'm looking at your ability, I'm assessing your understanding and your ability to find information. So we have now finished language production, and the chapters in the book now deal with language comprehension, which is the reverse going from auditory system to semantics. And when you're interpreting, you're doing both, and you're doing it bilingually. Okay, so it's pretty complex. So I'm following the topics in the book, and today we'll do chapter 7. And chapter 7 concerns some of the basic perceptual processes that are required to process the input linguistically. We'll especially look at spoken comprehension, and then I'm doing this baby crash course in phonetics and phonology with a focus on English. Okay. So before we do language, we also rely on some basic language processing, a sort of lower level processing, both at the auditory level and at the visual level. And these are perceptions, sort of perceptual processes for language. And for some of these, there are similarities in terms of like you access units, so like features, phonetic features in the speech input, graphic features or letter shapes in the visual input, but then there are also differences that have to do with the sort of modality. And there's also a very interesting effects that have to do with the fact that when we understand language, we tend to integrate across modalities. Okay, so the effect of like the visual input on auditory perception. So we'll talk about this. So we'll focus, typo, language processing. So some of these questions are, well, what are the kinds of perceptual skills that are necessary for spoken and written language processing? So these are bottom-up processes dealing with the signal. And how does our knowledge of language at higher levels, like the phonology, the semantics, and so on, influence perception? So how does our linguistic knowledge influence how we perceive language? And I use these two terms, bottom-up processing, thinking of going from more basic perceptual skills, that's sort of bottom-up, things, sort of acoustic cues in the input, and top-down, referring to in higher levels of knowledge, like, for example, context and semantics. Okay, so if instead of we hear sounds also based on our prediction or our semantic prediction as to what makes sense in context. So I'm using the term top-down processing to refer to these kinds of effects. So how do we recognize spoken language? How do humans do it? What's this balance between bottom-up and top-down processing? And what other factors influence how fast we are recognizing speech and words? Okay, so word frequency, which is actually a big effect. Frequency has a large effect in comprehension. Recency, what does recency mean? Word frequency, I think you can understand, you know what frequency, how often you encounter a word in either spoken or written. But what about word recency? Any guesses?
Maybe if you occur these words, like, I don't know, a few seconds.
Exactly, that's exactly what word recency is, right? So prior exposure, yes, that's word recency. Okay, so if I say that, I don't know, well, the word platypus is a low frequency word, but now I've said it, okay, you would actually be more likely to recognize it because it's recent. Okay, so then that activation remains in your network for a while, then it obviously goes back down. Okay, and also similarity to other words. So again, when we recognize language, it activates a network around it, like a neighborhood. So, and other factors like frequency, recency, and similarity. So, now we're going to go into a little bit of phonetics. Okay, so what are speech sounds? Okay, speech sounds are vibrations. They travel through a medium. The medium usually is air. Okay, and they travel like when you throw a stone in water. It ripple. You have those ripples, those waves. Those are waves traveling through a medium, and that's exactly what happens physically when you speak. So depending on the density or the consistency of the medium, the sounds move at different speeds. They have different intensities. So this is why, like, if you need air, you need a medium to hear sound. Okay, so you can't speak in a vacuum, and it's harder to speak underwater because the sound waves have a hard time traveling. So this is what sounds in general are, and speech sounds are a special subcategory of sound. And so speech sounds propagate in the shape of waves, and this amplitude is the degree of displacement, or sort of the height of the wave. Okay, so you can actually you can acoustically study speech sounds, and this subjective perception of loudness, whether something is loud or not, measured in decibels, corresponds to this amplitude, the amount of displacement in the sound wave. Okay, so intensity in decibels corresponds to our subjective impression of loudness. So you can describe sound waves physically. And in speech sounds are complex waves. Now this is, kind of like glossing over, but there's a whole bunch of maths under this, right? So you can, for those of you who did a little bit of physics, maybe in high school, that complex waves, so speech sounds are a composite of different, more fundamental sine waves that have this repeated pattern, okay, at different frequencies. And each speech sound actually has its characteristic frequency pattern. You can visualize it in a spectrogram, and phoneticians become very good at reading what kind of sound it is. Okay, so you've got amounts of energy at different frequencies. And the frequencies come from the pulses in your vocal folds. So your vocal folds emit pulses, and then this gets modified by your oral cavity, right? So in a way, when we talk, we're kind of like playing a very complex instrument. We're controlling this. We know that speech is special for humans, okay? So there's a lot of research going back to the 50s and the 60s that look at hemispheric specialization for speech. Right? So for most speakers, so for a majority of speakers and signers, language is lateralized, meaning one hemisphere is better equipped to process speech. It tends to be the left hemisphere. So we know this from many sources of evidence, brain imaging studies, neuropsychological studies. So like what happens when you've had a stroke in your left hemisphere? It damages your language. The right hemisphere has a different kind of consequence. And the Paul Warren book cites these experiments that you can do. So one thing about the brain, lots of things about the brain, but it is, it processes all the signals that come in from the senses, the body, and so on. It integrates them, and then it's responsible for sending out all of our motor commands. And the brain is contralaterally organized. What does contralateral control mean? So if I'm the left side of the brain, I control the right side of the body, right? So it's like information that comes in from the right side ends up going to the left. If I want to move, let's say, my right hand, the signal will start from the left hemisphere and cross over. So this is why you have this so-called, so the right ear advantage refers to the fact that if you give people linguistic stimuli in two auditory channels, one to the right and one to the left, you have this right ear advantage. Why? Because speech is then sent to the left hemisphere, and the left hemisphere, specialized for language, has an advantage. Okay, so there's an advantage in recognizing speech when it is presented to the right ear if you are left lateralized, right? If your brain has speech on the left. Okay, so this has to do with the fact that we have this contralateral sensory motor control in the brain. The left hemisphere processes signals from the right side of the body and vice versa. And we're also specialized, our auditory system doesn't only do speech, it does other noises too, etc. But we're especially sensitive to speech sounds. And this is the frequency range for speech sounds, between 600 and 4,000 hertz, the frequency. That's where we're especially attuned to. We're capable of distinguishing between speech and non-speech sounds, and even when we don't know what the language is, right? There's something characteristic about speech sounds, and newborns show this too. So there's something sort of special about speech. Now, speech turns out to be complex. It's not, every time we speak, it's a little bit different. So there's a lot of variability in the signal, depending on all kinds of effects, speaker characteristics, context, etc., right? So the signal is variable. And humans, to overcome this issue, actually manifest a series of unconscious, basically, mechanisms, and we'll talk about 3 of them. Then the kind of fun things to look at too, categorical perception. So even if the spoken signal is variable, we digitize it. We do this, categorical perception. We are also very good at integrating across modalities. So what we see in humans influences what you hear, which is kind of interesting. We'll see that, sort of magic. And then we use context, massively use context. So context means what we know about a language, let's say lexical status of a word, influences what we hear. Okay, so this is an example of a top-down effect in speech perception. So some of these unconscious strategies are what actually allow us to recover from this variability and be able to recognize this issue, right? So how do humans go from the perceptual input to the linguistic system? Because what you hear comes in as, well, sound waves, right? And then you are actually analyzing them linguistically. So this question, this issue known as the lack of invariance problem, okay? So the input is variable, both when we listen to language and when we read language. When we read language, there is an advantage. There are usually word boundaries. In spoken language, there are no word boundaries. Word boundaries aren't there. We hear them, but that's because these strategies kick in, right? So the more words you know, the more likely you can pick them out through the stream. And we know this from listening to a language that we've never heard before, that we're not familiar with. We can't hear, you can't identify words in a language you don't know. So these issues of variability also pertain to both spoken and written language, but specifically to spoken. Okay, so we don't mark boundaries between words when we speak. Every time we produce sounds, they're influenced by other sounds, so co-articulation phenomena are pervasive. We also do speech processing in very noisy conditions a lot of the time, multiple speakers and so on, so complex signal processing. So co-articulation,
Can I ask a question?
Sure, yes.
You talked about the difference between the written language and the oral language.
Yes.
But like in case of languages such as Thai, where there is no punctuation, does it influence the speaker's brain?
I don't know. I mean, I would say probably you actually have, where you don't have punctuation, you would probably then have issues having to do with segmentation, right? We tend to, I mean, probably yes, yes. So we talked about this, right? That probably, so the fact that we have phonological awareness, like the fact that we can actually do things like, I can say, I don't know, sort of pronounce the word mouse without the m. You would say, right? So phonological awareness is also supported by the fact that a lot of languages have a script based, and you sort of have correspondence between writing and phonology, right? So some of these effects will be influenced by the writing system. At the same time, I'm not an expert on writing. I sort of like what writing does. But there are, so, and writing is acquired, right? Writing is a cultural, like it's a cultural acquisition. Once we learn how to write though, we tend to specialize in terms of like brain, so that there are certain areas that are at the interface between the visual, like we recognize, we don't just recognize letter shapes as like very specific objects. We tend to specialize certain areas of the brain, right? And we do this language independently, meaning, for example, writing tends to be understanding where writing is. It's the left hemisphere towards the back. Let's say it's like towards the back. You wouldn't have, I don't know, writing in Chinese, frontal lobe on the right, okay? That doesn't happen. It would still be writing, recognizing the connection between written and spoken occurs somewhere in the specialized hemisphere. The other hemisphere also does some of this processing. So there are probably specific effects that have to do, with the writing system. So some variability, but the underlying circuitry would be similar. I don't know if that answers your question, but those are interesting questions to ask. And you're right, you know, like what's the effect of your language on how you do this? Okay, so okay, we're discussing now the issue that the Warren book also addresses, which is every time we speak, we're not speaking phonemes in isolation. We are co-articulating, right? So co-articulation has to do with the fact that every time we produce a sound, it's influenced by context, the phonological context. So speech sounds, technically phonemes, are influenced by the sounds that surround them. So in English, for example, and if I say p, the p sound, if I pronounce it syllable initial, word initial, as in pit, it'll be different from spit, okay? What's the difference here? Well, some things are the same, it's a bilabial, it's voiceless, but if I say pit, you've got this puff of air, it's an aspiration that comes from the fact that it's in word initial context, okay? And spectrograms show this. So one way to see this is looking at spectrograms. So if I say a b sound in bag versus bet, it's going to look different. Why? Because the next sound is slightly different. It's an a versus an e. So lack of invariance problem. It's like, well, then if this is acoustically different, how is it that I always hear but? Right? So it means I'm doing some very sophisticated kind of abstraction. I'm recognizing something as a category so I can actually recognize something as a category even if every time I hear an instance of that sound, it's going to be different.
So the spectrogram analyzes the phoneme, like it's like the letters.
Okay, the spectrogram shows you the bands of energy at different frequencies. So it basically makes that sound visible. Okay, so the spectrograms, we'll look at the spectrogram. Okay, so spectrograms show you that the input is variable. But you, human, are actually, you don't fall into that trap. You recognize it as a but. Okay, even if the spectrogram says, no, these are two different sounds. So physically, acoustically, they're different. But you have the ability to recognize it as one mental unit. So you've got this ability to be more abstract. Okay, so spectrograms allow us to visualize speech, and speech is just like an energy at different frequency levels. Okay, so these frequency bands are called formants. Each formant on a spectrogram uses color coding. The darker the color, that means more energy at that band. Okay, so we'll just look at the pictures. I mean, we don't have to read them. Okay, but this is an example. So the d sound in 4 different contexts. One, when it's followed by by e, by o, and by e. Okay, so the spectrogram looks very different. This means there's different bands of energy. And if you were doing speech perception just based on the spectrogram, you would be hearing different sounds. But you're not. You're actually doing something different, right? So you have this means that the human linguistic system is more abstract. You've got your concept, phonological category, d, okay? Here's another example of, so we're just showing what spectrograms do here. They just make speech visible, and they allow us to understand that we're doing something more sophisticated than just relying on this kind of low-level acoustic analysis. So spectrograms also allow you to see that when we speak, so moments of silence don't necessarily correspond to pauses between words. Okay, so there are moments in which we're not producing any sound that are inside a word, and moments and boundaries between words when we continue to speak. So we're not just waiting for pauses in the speech stream to put segmentation in there. We're doing something more sophisticated. So this is, you know, a spectrogram for the dog snapped at. Okay, so Here, the spectrogram is showing you these different energy bands that correspond to the pulses from your vocal folds at different frequencies and over time. Okay, so here's an example where some word boundaries in fact correspond to no sound. So the dog, like brief pause, yes, that's a word boundary where there's no sound. But here you've got no sound between the s and the n, snapped, when you see this on a spectrogram, okay, transition from s to n. And then here's an example where there is sound between words, okay, so snapped at. Okay, so we're not waiting for pauses to pick out where words are. So this is just to show that you're doing something pretty complex, where you're using some perceptual strategies. Some things are built into our perceptual system. For example, categorical perception and multimodal integration, and some have to do with our knowledge of the linguistic system. Okay, so the use of context. When we know words in a language, then this influences what we hear. Now we're going to take a little detour. We're going to do a little review of phonetics and phonology, sort of some of the basic concepts that the Warren book kind of takes for granted. Okay, so we said some of you have taken phonetics and phonology, have you? Some people have?
We studied a bit in general linguistics.
In general linguistics, okay, and some of you haven't. Okay, so we'll show, so for some of you these will be easy, some of them maybe not. If it's easy, it's easy. If it's not, please do not hesitate to ask me, because we could take, you could do a whole course in English phonetics and phonology. Okay, so across all human languages, there are about 200 sound units called phones. And one of the problems with a lot of writing systems, alphabetic writing systems, tend, they give you a rough idea of how something is pronounced, but they don't do this in a way that's systematic. For some languages, you tend to have units of writing that correspond to units of sound. Italian is more on that end of the continuum, where you tend to have one letter corresponding to one sound, but not always, because sometimes you have things like ñ, that's two letters corresponding to one sound. Then you have languages in terms of their writing system that are called non-transparent languages, like English. Okay, so the idea here among phoneticians is to come up with this conventional alphabet called the International Phonetic Alphabet that basically uses one writing symbol to represent one sound. Okay, so you have a one-to-one correspondence. So one phonetic symbol corresponds to one sound unit. And another thing we know about, I'm simplifying a little bit here, but there are two major classes of speech sounds. One class of speech sound is produced with no obstruction in the vocal tract, in the mouth, okay? Vocal tract is like the technical term, in the mouth. For the air stream that comes from the lungs, we, for many languages, use the air coming out from the lungs, coming through your oral cavity or your nasal cavity setting, and then you change the shape of this cavity and you modify it so that you come up with different sounds. So vowel sounds tend to be produced with an open mouth, no obstruction to the airflow. And then another class, which is consonant sounds, that are always produced with some obstruction to the airflow, either complete or partial, but always a constriction somewhere in the mouth or oral cavity. So this is what it looks like. This is sort of useful in terms of grounding speech in the body, because that's kind of, it's part of our body. So when we think, you think of like sign languages as being using body parts. You're also using body parts when you produce spoken language. They're just not visible, but you are moving body parts So the parts in this case, they're less visible, but they are nonetheless you require sophisticated movement in this case. And this is what's called a sagittal section. It's like the idea of slicing somebody's head. And these are the terms that we use to classify sounds. Okay, so we try to describe them so in terms of how they are produced. Okay, so how they are produced. And we'll see in a minute, and you're probably familiar with the chart, the IPA chart that classifies consonants in a table. This table corresponds to these various body parts, with the left part of this diagram corresponding to the front of the mouth, going from the lips, the teeth, the hard palate, all the way to the back. Okay, so this is especially useful for consonants. And then for vowels, you use the height of the tongue, the highest point of the tongue inside the mouth, and highest point, and whether it's that highest point is more towards the front than towards the back. So those diagrams that we'll see in a second that are sort of like, they look like tables, in fact correspond to parts of the body. Okay, so here's like a more stylized schematic diagram of the important parts of the body. These are also useful to remember when you think of the terms used to classify, for example, consonants. Okay, so if you're a speaker of a Romance language, if I say bilabial, that means at the lips. It involves two lips. Okay, dental. Right, so this is where you have an advantage for these terms when you speak a Romance language. So the lips, the teeth, the alveolar ridge, the hard palate, and the soft palate. And these are all sort of parts of your anatomy that you can identify. You can use your tongue to find these landmarks. Okay, you can identify where your alveolar ridge is. How do you say alveolar ridge in Italian?
Alveolo.
No, l'alveolo, la cresta alveolare. La cresta alveolare, giusto? Vero? Si chiama cresta alveolare, alveolar ridge, che è dietro i denti. There, cresta alveolare. Okay, it's a ridge in English because it's kind of like a little like a ridge. Then you've got your hard palate, and all the way back your velum and your soft palate. And then you also have this part here, which opens and closes, okay? And this is what allows air to either only come out through the mouth or to go all the way out through the nose. And then the parts of the tongue that are important are the tip, the blade, and the whole body, or dorsum. Okay, so this is how we produce spoken languages. Okay, so here are just drawings, okay? These are useful drawings. How are vowels produced? Air comes from the lungs, no obstruction. So mouth is always open to more or less, to a greater or smaller degree. So vowels are described referring to how open the mouth and the jaw is, and the highest position of the tongue. Okay, and these are this is the diagram of all the vowels, the single vowels, not the diphthongs. Okay, the monophthongs for English are here. Okay, so we'll go back to these, and we'll talk about those central vowels, the vowels that are important for English, including the schwa sound, the sound. Okay. And here I've highlighted them because these are, we said there are important differences between English and Italian in connected speech. So when you speak in English, you tend to, in unstressed vowels, centralize vowels. Okay, so spoken English has this characteristic. You can image speech sounds in isolation. So this is a spectrogram for the E vowel. And what this shows you, these are different frequency bands. These are different pulses. Okay, so if I say E, your vocal folds vibrate. That vibration is actually what produces these striations like this at different frequencies. Okay, the more intense the color, the more energy at that frequency band. So people who learn how to read spectrograms would say, oh, okay, this is an E sound. And here towards the end of the spectrogram, you see sort of this breaking of the regular pulses. So if you try to say E for a very long time, at some point your voice becomes creaky. You're no longer doing this, sustaining this vocal fold vibration. Okay, so these spectrograms for vowel sounds show us that when we produce vowels, the vocal folds, or chords or folds in the glottis is behind here, okay, vibrate at certain frequencies, and these pulses can be observed on spectrograms. Okay. How are consonants produced? We said, well, consonants are always produced with some obstruction somewhere in the oral cavity, either towards the front, the middle, the back, okay? And then, so this is how we describe them, okay? So just looking at this diagram, what sound do you think this could be? What could it be? So the tip of the tongue is contacting somewhere here. It's not the teeth, it's what
R.
Could it be an R? It could be an R. It could also be a sh. It could be a L, and it could also be a sh or L. Yes, L, R. Okay. It could also be, I mean, this just tells you the place, like where this is happening. Okay, so there are lots of consonants in English that have this place of articulation. It's called place of articulation. And another important distinction is whether these consonant sounds also involve voicing or not. Voicing refers to whether your vocal folds are vibrating or not. Okay, so if I say t or d, I'm doing same place of articulation, but I'm also kicking in vocal fold vibration. And we'll see how this is interesting, like the timing of when it is that we also activate vocal fold vibration. So we said place, whether there's voicing or not, and then another parameter to classify consonants is manner, right? So what's the nature of the obstruction? Is it complete, like when I say t or d, k or g, or is it a complete closure, or is it just a constriction of the air flow? So manner is the third element that you need to describe consonants. And given these three parameters, you can describe any sound in any language. Okay, these are the basic ingredients of how we do classify consonants. Okay, so this chart, the International Phonetic Association classification for the consonants for all languages, uses one conventional symbol to represent any sound, and they are classified, as I said earlier, in this chart that corresponds to anatomical points. Starting from the left corresponds to the front of the mouth, going all the way towards the back. Okay, so you read it left. Remember what I showed you, the diagram of the mouth going towards the back. This is what the chart is showing you. So for Italian speakers, bilabial. This gives you the 2 points. It means the 2 lips are involved. Pa-ba. Then you've got labiodental. Okay, so we don't have labiodental. So sorry, let me just go back. So bilabial, labiodental, dental, alveolar, postalveolar, palatal, velar, uvular, pharyngeal, and glottal. Okay, all the way to the back. And then the way in which the air is constricted, either completely, as in plosives, also known in English, plosive, or stops in English. So stop is also a sort of synonym for plosive. Why are they called plosives? Because typically when you produce a plosive sound, your articulators come together and then they go apart. And usually in many languages, this is associated with a release of air, like this little explosion when you release the stop. That's why they're called plosives. What are nasals? Nasals also have air coming out of the nasal cavity, okay? And then we've got fricatives, lots of fricatives across the board, different positions. Now these are the consonants for all languages, okay, all possible languages. So each language picks an invention, their consonants. So here, and each symbol corresponds to one sound. Okay, so you're transcribing English, for example, and you want to, a word like there, you would use the sound and the th sound. Okay, so this chart is convenient because it shows you how to produce them and how to transcribe them. And this also shows you the pairs, when you have pairs of sounds. So these symbols, these aren't letters, they are symbols that correspond to one sound, right? Remember? So writing systems don't have that one-to-one correspondence. You have different conventions in different languages. So for example, if you're Italian, gnocchi, you write it with j, g, n, but that's not the way you would write it in phonetic alphabet. What would you use to write gnocchi? You would use this one.
Yeah.
This one with a long, no, palatal one, this one, sorry, this one, the ñ, palatal nasal, ñ, right? And this one's this one's a velar one, which you use in English. The this one. Am I showing? Is it the cursor going? Okay, this is the long one here. Is with the corresponds to the velar nasal in English. What's a velar nasal sound in English? Give me a word with a velar nasal sound in English. Sing, like to sing, song. That's the velar nasal. Okay. And in Italian, you have that sound, but it doesn't distinguish between pairs of words. It isn't a phoneme, it's a sound. So if I say fango, you do have a velar nasal before g, but fango, fungo, right? But you don't have words that contrast with that sound, like sin and sing. Okay, so languages can have the sound, but they don't use it as a phoneme. Okay.
And can I ask you for doing? What's the sound?
For what?
Doing.
Doing. Okay, ing always is doing. Yes, that would be doing.
Okay.
It's not.
It's the same as sing.
Yes, it is. Yeah, and you don't have the g, right? It's not sing, it's sing. Doing, skiing, talking. So it's ing is always. Now in fast speech, you can then have things like, how you doing? That can happen, but if you produce it in isolation, it's okay? Yes. So ing is in English, Yep. What else? Okay. Here's an example, right? Bilabel. So I'm just showing you pictures of manner now. Bilabel plosives, also known as stops. The lips come together. Alveolar plosives here at the alveolar ridge. Velar plosives are harder to see, but at the back, k, g, k, g. You can actually practice these. It's good to have awareness of your speech sounds. You could simulate. We have so that you. When I teach phonetics and phonology, it's important to develop what's called proprioception, like awareness of where I mean, we do it naturally, but you can also pay attention to what you're doing when you're doing it. And it's a good skill to have. Okay, so proprioception. Labiodental fricative. You can do this at home, okay? So, now just this very rapid introduction to speech in isolation, but when we speak, we don't say speak, we don't produce sounds in isolation, we don't produce words in isolation. So there are lots of speech phenomena that have to do with connected speech, right? So when you learn phonetics and phonology, you learn how to do transcription of words, which is how you find them in the dictionary, called in citation form. Okay, so if I say the word cat in citation form, we love the word cat. Okay, so how would you do it? Would you say k, a, t? Okay, but in connected speech, you have all kinds of phenomena that occur both in English, in Italian, in many other languages. English has a series of phenomena that have to do with connected speech and speech rate and so on that have consequences on vowels. Okay, so English versus Italian, you have big differences in how vowels are produced in real-time speech. Okay, here I've just listed a very common process in English, which is the fact that your vowels tend to become centralized, okay, reduced and ultimately dropped. Okay, something that happens is also called co-articulation and assimilation. Okay, we'll see. So speech sounds take the characteristics of surrounding sounds. So I'll just show you examples of assimilation. And the more accustomed we are to understanding a language, the more we sort of ignore these. We don't get sidetracked. Okay, we don't misunderstand a sound. We use context. We know what we know. We know we can recover from these processes. So these phenomena are called suprasegmental aspects of speech. They occur above the individual sound unit. And they have to do, for example, with speech rate. The faster we talk, the more likely we are to produce these phenomena. They also have to do with stress. Now, stress is a complex, multidimensional property of speech. It tends to occur on, well, words, syllables, and so you can have word stress, phrase stress, utterance stress, and intonation. So this has to do with all the prosodic aspects of speech that are required to both comprehend and produce spoken language. Now, here's a very basic example of the effect of tempo or speech rate, how fast we talk on the quality of the vowel. When I say quality of the vowel, it's the nature of the vowel, what you actually end up saying, okay? So if I am talking slowly, I might say, I can go. Okay, you don't do that in speech. You would say, much more likely, I can go. I can go, or in fact, drop the vowel altogether. I can go, right? This happens all the time in spoken. Okay, so phonetically what happens? I am centralizing. Okay, so in this case it would be the a becomes, I end up producing a. So that's an example of centralization. It means that you tend to use a vowel that is produced at the center of the oral cavity with a mid-tongue height. I haven't given you all of the parameters of vowels, right? So length and whether they are tense or lax, etc. So the vowel system in English would take a whole lesson, more than one lesson to go over, but these are like basic concepts. Okay, so centralization happens a lot, and centralized vowels. So this capital E vowel. You have done English phonetics and phonology, yes?
English.
Not English phonetics and phonology.
It's
Never?
Just general.
Just in general. Okay, so maybe we'll do, well, if you want to do another one, we can do it. But, so for example, this capital letter, short, it's called short E, is the vowel in words like, does anybody know? So this one, you know this one here at the top, because that's a cardinal vowel, that's E, okay? So if I say seat, sheet, okay, don't say the second word, but if I use this one, it's a little bit lower, sit, okay? So this is the high front vowel in English, which tends to be long, and then you've got the slightly lower one, sit, okay? So these are, so Italian has this one. Italian doesn't have this one. And then you've got the second vowel here. In English, doesn't really occur in a monophthong. It occurs in diphthongs. Like if I say, a, okay. So this is e, doesn't happen. And then you've got this one in English, e, and then you've got a, as in cat, and ah, okay. Then here in the back, why are these called front vowels? Because this is the highest point of the tongue towards the front. And other parameters for vowels are lip rounding, whether you also round your lip. So your front vowels are not rounded. In English, your back vowels tend to be rounded, like if I say all, right? And so the other parameter is how much energy you put when you produce into producing the vowel. So E, you're using more energy than E, okay? So for vowels, you use this front, back, and tongue height. Maybe we can do a little bit more about English vowels, not today, but this is the oo, okay, as in, give me a word with oo in English.
You lunatic.
Lunatic, yes, moon, and then this one is the oh, so it's like in book, okay, so and then you've got another vowel here, the upside down one like this. That's a back vowel in English. It's kind of like an but it's the vowel in words like up, luck, okay? And then this one that looks like a 3 is a central vowel, kind of like a schwa. So schwa is that's the, okay? If you make that a little bit longer, as in, now I'm going to say British version of the word bird or girl, okay? So it's still an but it's longer, okay? It's sort of like a long schwa. So bird, word, girl, that's this central, it's a tense vowel and it's longer than the schwa. So schwa is the one that you produce when you produce the reduced form, meaning the spoken or the unstressed vowel. So if I say can, okay, can you stop, you know, can we go, can we leave now? Or you would stress it. Or if I say can you do this? Could you, can, right? So that's where that unstressed syllable in English becomes reduced and centralized in spoken. So, instead of saying, if I say, in unstressed contexts, for example, you can also produce, or if you're speaking fast, instead of saying the whole front E, you might say, instead of saying, you might produce the shorter version, right? So this centralization process is relative, okay, relative to what the full vowel would be. So stress falls on syllables, and stress is complex. It's not just loudness, but stress syllables tend to have cognitive prominence, that perceived as being louder relative to others. They tend to be longer and higher in pitch relative to other syllables, and stress falls on the nucleus or the vowel sound of a syllable. So the vowel carries stress. So stress syllables have cognitive prominence, and speakers know this. They exploit it in production. If I want to say can versus kun, okay, I might be doing it for various reasons, including either, well, speech rate, but it could also be pragmatic. If I want to say can you or kun you, that's different meaning, okay? So speakers produce this for various reasons. And listeners also know this. Remember in the Warren book when it said, so clearly, if I say can is clearer than kun. But if I say can when I should be saying kun, I'm not conveying the pragmatic message, right? So this alternation between when it's contextually appropriate to use a reduced form versus the full form, in this case would depend on pragmatics. So listeners know this, okay? So they recognize this and make these connections based on contrasts with other syllables, and then can exploit this for pragmatic reasons for comprehension. Okay, so here's an example of where it would be just a simple, silly example, right? So the mother, you can't go out without a jacket. The child says, yes, I can, right? I'm stressing can, yes, I'm emphasizing this, so I'd use the full vowel. But a different pragmatic context, who can go out and buy milk? I can go. Not I can go, I'm not stressing can. Okay, so these function words, modals, and function words are very often prepositions. They very often are not stressed. Okay, so they don't. So they often occur in a reduced form, and if you do stress them, that carries meaning. Okay, so here's this example. Simply shows you what happens to the vowel sound in English. And this is something that wouldn't happen in Italian. You wouldn't change the quality of the vowel based on pragmatic meaning. Okay, so these are phenomena that have to do with spoken production and comprehension in English. And you can describe them phonetically, easily. Now here are connected speech phenomena that happen all the time, and any language has this. Okay, so assimilation refers to the fact that a phoneme sound becomes modified. It acquires a feature, typically, of a following sound. Okay, so this is called, for weird reasons, regressive assimilation. So I'm still in bed. So a person actually produces a m sound. How do you explain that? When I say in bed, or how would you describe this? The fact that you've got the bilabial feature that gets anticipated on, right? So the n acquires the bilabial feature. It's still a nasal, but you actually end up producing a m sound instead of a n sound. So that's an example. It's a common assimilation process having to do with place assimilation. So place assimilation makes sense because when we're speaking, we're looking ahead, right? We're moving our articulate. So if you think of speech sounds as movement, you're moving ahead to get to the right place because you're doing something that requires this rapid transition between different places of articulation. There are various other connected speech phenomena. I'll show you more examples of assimilation, but liaison or linking, wait for a moment, okay. Elision, when you drop a phoneme, so next, instead of saying next, please, you say next, please. You don't produce a t. Okay, that would be an example. And these are there's tons of examples. These are pervasive phenomena in spoken. So the idea, you know, that we are recognizing phonemes in speech, it's like, well, if you just went by the phoneme, you wouldn't be able to recover meaning. So we're doing something else too, right? We're using top-down information to understand speech. Okay, so here are some of the processes. We said for English vowels, think of centralization as being an important process. For consonants, assimilation, liaison or linking phonemes, epenthesis, and elision. They sound like diseases, but that's, you know, epenthesis, adding a phoneme, elision, dropping a phoneme. So we said assimilation happens a lot in spoken production and comprehension, and this sort of later to earlier called regressive assimilation is very common. Okay, so I can bike, again, very common. So here are just some examples. Okay, so something happened here, fat man, that guy, bad boy, can play, horseshoe, right? Those are all assimilation. So it's the place gets anticipated onto the preceding consonant. So we expect this in speech and we can recover from it easily. Okay, here are examples of liaison, law and order, my arm, go away. So these are common linking, they're called linking. So these are semi-vowels, so y and w, so go away, my arm. Those are also common. There are a ton of useful sites to either, you know, go over phonology, you can click on the charts and so on, and to transcribe. Okay, so here's just one that's interesting to look at. Let's see if it goes there. This is nice because you can actually click on the chart and hear the sound. Where is it? The interactive IPA chart. Maybe you know this one. Yes? No? Right, it's not loading. And also from this International Phonetic Association website, if you go to education, the education tab, and you're curious, you can see there's a ton of really useful resources for all kinds of dialects and languages and so on. Okay, so if there's a dialect you're not familiar with, a speaker that speaks a dialect that you don't know, you can actually go and look. So there's a ton of resources for all of the varieties of English, but lots of other languages. So it looks like we have 4 more minutes. What are we going to do in 4 minutes? What are we going to do in 4 minutes? Okay, let's just do one thing. Okay, so we finished phonetics and phonology. Now we're getting back into Warren. Do you want to do one last thing, or are you tired?
Can we have some further information on the presentation?
Oh, sure, yes, yes, okay. All right, so have you found a partner?
Yes, just pairs or can we have more than 2?
So well, what do you think? I mean, I think 2 is good to work because 3 gets more complicated in terms of like coordinating. It's easier, but if you prefer, I mean, I think 2 is ideal. Yes? Okay? And then you have to discuss amongst yourselves what paper you're choosing, how you divide, you want to read it. You maybe then once you've selected it, I suggest 1 person per group email me. I mean, I don't micromanage. I in the sense that so you tell me, okay, we thought about this one, and I'll write and say, is this okay? if you want to discuss it with me too, we can also discuss what elements you want, like what some of the, how you obviously want to read it and then decide, because if you're doing a presentation, you're not doing it for yourself, you're doing it for other people, okay? So that's a way to really understand, like I've understood something, I've selected it, and I'm telling you about it. That's the goal, okay? I'm not quizzing you on the content of the paper. I'm looking at this, I'm requiring you to do the work at home, which also means, okay, this is too hard, this is not relevant, this is too much, okay? So it's not, have you memorized the paper? I'm sure there are parts of the paper that are difficult, and you maybe say, no, this is not relevant, or I don't want to go there, or if there's like some difficult statistical analysis, you don't go there, you decide, I'll show the graph, right? So we'll talk about a little bit how to read these papers. So papers, what would you do? Read the abstract, okay? The abstract is, well, what did you find? What, like, if I were to write a news report on this finding, what would that be? What are the highlights? Okay, what's the method? How do they do this? Like, what were the questions? So often these papers actually have research questions, and then they say something about, well, why is this important? What have people found before? Okay, that's typically what they do in the introduction. The method, then the results. Okay, have you thought about them?
No, but there are very long articles, so that's why we asked about 3 people, because
No, you have to read, each person has to read all of it.
no, yeah, but maybe the presentation is a little bit.
No, you can say, well, that means, you don't have, so that you have to be selective, okay? That you don't have to go through all of the parts of the paper. So there'll be the background, and so it's basically saying, all right, you read the paper, but she didn't read the paper, and she's not going to read the paper, but can I present her with like a summary, like if you were saying, she's a journalist, you're the person who's done the study, like, okay, so it's important in the paper. So the reason why people write these papers is also that if somebody else wants to do the study, they read the paper and it's like a recipe, everything I did, and this is how I did it. And the idea behind this is somebody else wants to redo the study, they follow that procedure, they should be able to replicate it, okay? But if you're reporting like what was interesting or about this paper, what study was it, okay, you don't have to go through all of that detail. Yeah? Have you chosen?
When will we be presenting?
Well, at the beginning of December, when we're done with class, okay, we'll pick a date where we do presentations.
Or like everyone in the same day.
If we can do everyone in the same day, yes.
How long will
long?
that be?
Yeah.
About 30 minutes,
Each group?
yes. I mean, total,
So
like
in a
20.
day will not be possible to do all of us.
If are you all doing presentations? You think you all want to do them? So 30 minutes, okay, so it could be 2 days. Okay, I mean, so roughly, not more than 30 minutes, okay? So like 20, okay, just to have it like, okay, this is what the paper was about, right? So I'm saying 30 max, it's just not, right? That's the idea.
Is there gonna be also a written exam in December, right?
So if you do the presentation, I'm basically assessing like okay, I've read something. The written exam, if you want to do it in December, because we have the sessione in January, if you want to do it in December, we'll do it in December, okay? So it'll be a question like, okay, explain how the model of production works. Another question maybe so that I see that so I'm talking to people who come to class and who I've, kind of know and interact with, okay? So it's saying, all right, have you understood the class? Can you go and, I say something about the production model or whatever, can you actually, it's an open book exam, right? So it means that you can actually go there. The written is, I have some time. So she's not like out of blue asking me something. I can actually, okay, I have some time to write this out, think it out, okay?
So,
Yeah.
there will be different answers.
So if you are non-frequentante, you would have more, but this I will do maybe 2 or 3 questions, one about production, one
With open answers.
with open answers, right? So short essays. Example, I told you I would already do this. I said, okay, here's a verb in English. Come up with a sentence. How does the model of language production explain how you do this? Okay, so you could sit down there and say, okay, my sentence is, I don't know, she baked big brown, something like that, right? How, I mean, I would give you a verb, so it means how would the model, so you come up with a sentence, I'll give you the verb, you come up with a sentence, and then you explain how the model works, what errors could happen. So then it's easier if you actually have time to write it down, okay?
Okay. And
Yes?
we already picked dates.
Yeah.
Could we already pick dates? Sure, let's pick dates. So do you want, I mean, I think this is easier if there is a class coordinator, right? So if you tell me what works for you.
Yeah.
We propose you
Yes.
a date. And
That sounds good.
It's good for you.
I'm sure if it's good for you, it'll be good for me,
Yeah.
okay? Just don't do it on a Sunday. I mean,
Okay,
we could, Sunday, right?
For example,
On the
Yeah.
25th.
Right, you got it.
it's
Yes.
just that she's not gonna be here in December, like.
Okay, so she can do it earlier?
No.
Oh, you're not?
No.
Okay, that's something
We will
you
discuss
propose,
it.
you will discuss it, okay? So it's good if you're obviously if somebody has a plane ticket and they're flying to Peru or whatever, no. So I mean, it's a small class, it's a small group, you actually work out what works for you, okay?
Yeah, no problem.
And you can do it in the morning, you can do it in the evening, I mean, as long as it's open and we can, right?
So we can also do them outside like our
Yes,
slot,
yes.
time slot.
Yes, yes,
Okay.
yes, you can, okay, so, because you're the ones, you've got labs, you've got all kinds of things, okay? So if I can't do it on a Wednesday afternoon because I have consiglio di dipartimento or whatever, but I would let you know, but I'm pretty, like, my schedule is flexible that way, so if you prefer to do it in the evening, we can do it in the
As you
evening.
got a presentation, what if, different groups, choose, for example.
You negotiate it, maybe you can, okay, that's something you negotiate.
Okay, or is it?
Try to choose different ones, right? So then the idea is, okay, I've heard about something else that's kind of interesting, right? So if you're the presenter group, you make the effort to make it digestible to other people, okay?
Would be questions at the end of the presentation?
Yes,
For
I mean,
example,
discussion, yes, so it's a non-threatening kind of thing. The point is no, I mean, and I mean it, so it's saying, discussion, well, what about this? And I could ask you, so what did you find hard about this paper? And or curiosity, it's like, what if you did something? It could even give you an idea for tesi, right? It's like, oh, things like that, right? It could, it's like, oh, okay, I hadn't thought about that. What would I do? So the point is to exercise, so do this task of reading something admittedly hard, because that's primary literature, meaning that these are the studies that the people do, like scientists do in different areas. I've deliberately chosen some that have to do with interpreting, some that have to do with bilingualism. We said, maybe those are just the ones that I came up with, but maybe you have another interesting one from there, and you're like, I want to see how language works in a different script or something. I mean, yeah?
So
Is this?
kind of us giving a lecture?
Yes, that's exactly what it is. Yes. And being yeah, exactly. Coming up here and, sitting here like I do and just kind of like, okay, so, I mean, when you're lecturing, I'm sitting over there. I'm a student, I mean, okay, so you're doing that. You're actually also practicing, becoming comfortable with standing up here and talking about something that you will know more than everybody else, because I'm not gonna read all of those papers. I've, some of them I've read, but you're gonna tell me about it, yeah? Obviously, I've read so many of these papers, and I'm a little bit, I'm practiced, but it's not that I know, that I will know, you will be the expert in that case, okay? And people are, and you do this as a group, from the beginning, you've asked questions, that's the spirit, okay? It doesn't, yeah?
Okay.
Sound good?
So we can prepare some PowerPoint.
Yes. Yeah, and again, that's your choice, and I think PowerPoint is really helpful, because it allows people to, you can, I'll show you, for example, if you want to cut out parts of the paper like the graph, you do screenshot and you paste it in, and you're like, okay, well, this is what they found, and you explain what the graph means, if it's a graph, right? This is, yeah?
Okay, thank you.
Okay, sounds good, all right, so see you next week. And, okay, I want to make sure I don't, delete the videos, so. Did it, interrompi registrazione, right?
Yes.
I'm terrified already.
You can do it.
Okay.